We are still looking at lesson 4.2. Now we're going to look at task 2, and we're talking about linear functions. So if you want to follow along, pause the video, find task 2, and we'll get started. Alright, so to graph a linear function, you can represent an equation like y equals 3/4 x plus 2 graphically by choosing x values, finding the corresponding y values, and then plotting the pair, your ordered pair, your x and y values, and drawing a line through the points. Alright, so they've picked some points. They've chose a negative, 0, and positive points. That's a good variety of points. And then they plugged each one of those into the function to find the y value. Alright, once they did that, then they graphed these. You can see that negative 1 goes up 1.14, or 1 1/4, and then 0, 2, 1 is 2 3/4 of the way up, and then 2 and 3.5. So they've used those points to draw a line. So that's a linear equation, and using a table of values to graph that line. You can also use the y-intercept and the slope to obtain a graph of the equation as well. So I think most of you guys probably did this in 8th grade math last year, so this should be a review. But we're going to look at this again. So we've got 3/4 is our slope, and 2 is our y-intercept. So you're always going to start with the y-intercept because you know the y-intercept is going to be on the y-axis. So you've got the y-axis, your vertical axis here, and you start at 0 and you go up 2. So that's how you graph the y-intercept, the plus 2. So you start at 2, and then you can use the slope to go rise over run, okay? Remember, our slope is rise over run. That's our changes in y over our changes in x. Alright, so we're going to rise 1, 2, 3, and we're going to run 1, 2, 3, 4. Now it looks like they've run first and then rise, which means they're starting with the denominator. But I always like to do rise over run, so I go 1, 2, 3, 1, 2, 3, 4, but you can see we end up at the same location. Alright, it says choose the words and numbers to best complete the explanation of how the y-intercept of 2 and the slope of 3/4 are used to obtain the graph of the line. Alright, first the y-intercept is plotted at 0, 2, so we started and went up 2, and then the denominator of the slope tells you to go, alright, again, we went up 2, and then the denominator, the 3/4, the denominator moves you over 4 units to the right. So 4 units to the right, and then the numerator tells you to go up 3 units. Alright, and that obtains the next point, and your next point, if we went from 2, either up 3 over 4 or over 4 up 3, that puts us at 4, 5. So the other point is at 4, 5. Alright, it says if you replace the fraction 3/4 by an equivalent fraction, okay, think about what an equivalent fraction is. So if you have 3/4, an equivalent fraction would be 6 over 8. Alright, if you replace this by an equivalent fraction, in problem A by the numerator and denominator by an equivalent fraction, would that still produce the same line? Choose the words to complete the answer. Alright, so let's look at that. Okay, so all we did was multiply each of these by 2. 2 times 3 is 6, 2 times 4 is 8. So that is an equivalent fraction. So if we go back up to the graph, if we go up 1, 2, 3, 4, 5, 6, and I go over 8, do I still end up on that line? Yes, I do. Okay? Alright, so the procedure would produce the same line because the triangle formed by the new arrows would always be similar to the triangle in the drawing. Okay, so when we're talking about a triangle here, they're using this the movement that they're doing to create this triangle here. And if you went over 8 and up 6, that would create a similar triangle. Okay. All right, it says match each equation to its graph by plotting the points. All right, so this is important because we have learned that if your line goes uphill from left to right, then it's a positive slope. If it goes downhill, it's a negative slope. So we can see that this is negative, and this is positive. We've also learned that the number on the end now is your y-intercept. So we can see that this one has a positive 2, and both of these have a negative 2 as a y-intercept. So this one has a positive 2, and it has a negative slope. So we can automatically go ahead and put that one there because of the negative slope and the positive 2 y-intercept. All right, so this one has a negative slope and this one has a positive slope. So if we look at the slopes, this one's positive and this one's negative. So again, they have the same y-intercept, but we can tell by the slope which line goes with which equation, or which graph goes with each equation. All right, we can check that, and hopefully that is not too difficult. That's an easy way to match equations with graphs, is by looking at the slope and the y-intercept. All right, if you have any questions, please let me know. Okay, still looking at 4.2, we are going to go ahead and look at task 3 as well. So if you need to pause the video and find this, you may do so. All right, we're looking at linear functions, and we want to apply a linear function in the real world. All right, so a function whose graph on an interval of the x-axis is connected with no gaps or breaks is a continuous function. A linear function is a continuous function on its entire domain. All right, so if it has no gaps or breaks, that's a continuous function. However, when a linear function models a real-world situation, the domain might be restricted because not all real numbers are reasonable. A function whose graph is made up of unconnected points is a discrete function. All right, so a lot of times we use discrete functions to model real-world situations. All right, Cameron received a Balloon Tea gift card for his birthday. All right, I don't know what that is, but hey, an $80 gift card is pretty nice. All right, so write a linear function for the amount A in dollars left on the gift card after X bubble teas are purchased. Then graph the function. What does the value of A of 20 represent in this situation? All right, so write a verbal model. So the first thing, the amount left on the gift card. So they're going to call that A. And the initial value, it said that he was given a gift card for $80. Right, here's the gift card amount. And it says each bubble tea is $4. So the initial amount is $80. Each time you buy a tea, it's minus $4 times the number of cups you purchase. So that can be written as a function. A of x equals 80 minus 4x. All right, choose the word to complete each sentence about the function where no context is involved. All right, so if we simply have this function and nothing is involved, like we're not talking about this problem here, so no context is involved, then the domain would be all real numbers because it would be continuous line in both directions with arrows. The range also would be all real numbers because there would be no restrictions. All right, if we add context, like talking about the gift card and the bubble tea, then that will change. So it says graph the function, only non-negative integer values of x make sense in the real world situation. So A is a discrete function. All right, so the number of bubble teas. So we go from 0, 4, 8, 12, 16, 20, 24, etc. All right, here we're going 0, 10, 20, 30, 40, up to 80. Okay. All right, it says, why is it reasonable to show only the first quadrant when graphing the function which models the real-world situation? Well, it doesn't make sense to have negative money on a gift card. Like, once your gift card runs out of money, you just throw it away. There's no negative numbers on there. You can't, it's not a credit card, it's just a gift card. So when the money is gone, that is all you can do with it. It just turns into trash, so you throw it away. So we don't need negatives here. Also, you're not going to have negative numbers of glasses of tea. So again, we don't need anything except the first quadrant. That's only numbers that would be reasonable. All right, so choose the words or numbers to complete each sentence about the graph function. All right, so in this situation where we are talking about the discrete function, where we're talking about the domain is going to go from 0 to 20, and the range is going from 0 to 80. Now, is it going to be all points in between there? Well, no, you can't buy a half a glass of tea. Each tea costs $4. You can't say, can I have a half a glass for $2? Like restaurants, like it doesn't work that way. So for the domain, it's going to be only the numbers. Well, the domain's going to be cups of tea. So whole numbers, 0, 1, 2, 3, up to 20. And then the range is going to go up to 80, but it goes by $4 increments. So it goes 0, 4, 8, 12, and so on. All right, so A of 20 is the x-intercept on the graph and is equal to 0. It represents the amount on the gift card after Cameron buys 20 bubble teas. All right, if you have any questions, let me know.